Alright, we're going to look at of hippos and whales. So this is a look at whale fossils and whale evolution, the history of whales. We're going to look at ancient fossils and ancestors of whales and how they might compare to a hippo. She is having a very bad day. So this is a killer whale. It is a orca, which is a type of toothed whale. It's not a true whale as they call it. It's a giant dolphin, really. But we'll call it a whale for today. It's close enough. So what could have been an ancestor of these giant swimming mammals? What could have been alive way back when that could have not been a whale, but then their descendants, you know, their offspring, their children, their children's 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 children's, and on and on and on, would eventually become whales. What kind of animal do you think would that have been? Well, if you said a hippo, you would be kind of right a little bit. Not really, but a little bit. That's about as close as we can get, because the only thing that's still around today that was most closely related to the ancestor of whales would be the hippo. So long ago, about 57 million years ago, I think it was, the ancestor of both hippos and whales was alive and thriving. And one group of this creature turned into whales, and one group turned into hippos. So the whale's closest living relative that's not a whale is the hippo. And we're going to look at some fossils, and we're going to talk more about how people have come to that conclusion. So we're going to focus specifically, mostly on the blowhole. So we know the blowhole of the whale, right? It's its nostrils. It's where it breathes through. Like we breathe through our nose. It's the nose of the whale, but it's on its head, right? So that's an interesting thing. So let's see how that happens. See what fossil evidence we have for changes like that. So we're going to start here with this diagram. So at the top we can see that there's a bar showing millions of years. So we're starting at about here. That's about 57 million years ago, okay? And then on into the future, we get different changes. We have different branching off points at different times, right? Where groups went one way or another, and one group of animals, you know, changed into this, and one group of animals changed into that, and all along, you have lots of extinctions, a lot of different animals diverging into different ways, and this group goes extinct, but this group keeps going, right? So we're going to start with Pakicetus. So here with the blue arrow, we have Pakicetus. Okay, that is not a whale. I don't know if you can see that's not a whale. That's not a whale, right? So you can see the skull of it, and here's why I'm not going to talk too much about the skull, because this is all of the skull that we have. Right, in the black is what we have. The rest of it is our very best guess with, you know, lots of brilliant minds and hard work and lots of arguing and, you know, some comparison and a lot of comparison to other fossils. So what we don't have is we don't have the nostrils. So we're not going to talk too much about it. But what we do have is there's a bone in the inner ear, which would be somewhere, I don't know, around in here-ish. And oddly enough, these bones very closely resemble the inner ear bones of whales and nothing else. Whales have very strange ear bones, and so does Pakicetus. This is one of the very good clues that we have that this was likely a whale ancestor. So from Pakicetus, if we go more years into the future, we get Ambulocetus. And Ambulocetus is not a whale, obviously. You can look at that. It's got arms and back legs. But if you look, can you tell it's starting to look a little more whale-like? Those front arms are a little bit shorter, right? A little harder to walk on land like that. You'd kind of be dragging your belly at that point. And look at the size of the chest on it. It's getting a pretty big chest on it, pretty strong chest. And its jaws are a little bit longer, right? So we weren't going to look at Ambulocetus's blowhole. I could not find a good picture of it. So we're just going to, or sorry, nostril, because it was not a blowhole. And we're going to look at Rhodocetus here. This was even more into the future. At 47 million years ago, where's Rhodocetus's nostrils? Where's his nose? It's not in the very front, is it? So if you think about it, think about dogs. You know, where's your pet dog's snout? Or nostrils. It's on its snout, right in the very front. Okay? Rhodocetus, not so much. How many animals do you know that have nostrils on top of their snout? It's pretty rare, right? Doesn't really happen. Not these days. You might think, well, hippo, right? Hippo's got nostrils up on the top of its snout, but not really. Here we have a Rhodocetus skull. Can you spot where the nostrils are? If you said right there, you're right. It is not in the very front of the snout. It's in the middle of the snout on the top. So earlier I was talking about a hippo, and I thought that was the next slide, but it wasn't. So let's see. This should be a hippo. Ah, that's a hippo skull. Believe it or not, that is a hippo skull. Now, if you look, it's not on the top of the snout, is it? It's in the front, like you would find in a dog or a raccoon or a possum or I don't know, I can go on and on if you want. So that is obviously not a blowhole. It's in the front of the snout, right? But now let's look at Zigoriza. I'm probably saying that wrong. So at 43 to 34 million years ago, we're getting even newer, right? We're getting even closer into the future. And you can see where the the nostrils are on Zigoriza, right? They are even closer to the eyes, right? And this thing is looking obviously much more whale-like. Much more. You can see its arms are not very useful for walking. And if you look at its back legs, these are its back legs. You are not walking anywhere with those. It might be able to lumber up onto a beach, drag itself back with its arms into the water. That's about it. So, looking pretty whale-like to me. But the blowhole is not there yet. The blowhole is not there. Nostrils are there in front of the eyes. This is what you see at the top, the skulls at the top. Nostrils in the front, nostrils in the middle of the snout, and then nostrils behind the eyes and a blowhole, right? There's another creature a little further into the future, Durodon, Atrox. You can see the tiny legs, the vestigial legs. Vestigial means that it's not used anymore, it's forgotten, it's wasted away. There's no use for these really, okay? There maybe it had a small flipper, a little something, but that's not legs, right? Those aren't legs anymore. And those certainly aren't front arms that are going to be doing anything on land. I don't even think they could touch the ground. Those are flippers. And I messed up on the arrow, I don't know why it moved. But if you look where the nostrils are on this creature, they are in the middle of the snout, a lot like we saw with our previous examples, right? So it's not at the front of the snout, it's not behind the eyes, it's in the middle. And obviously you can look at this and tell this is basically a whale, right? So we don't have the blowhole, but we have basically everything else that we need to call this a whale, skeletal wise. And then we have Cotylocara, I'm probably saying that wrong. at 35 to 24 million years ago, getting even closer into the future, right? Now we have a blowhole on this creature. It is behind the eyes, all right? This is a legitimate dolphin, we could say, right? This is basically getting into a dolphin. And now we have the orca, the killer whale. It's not a true whale, so I don't know why I put whale there. It's basically a dolphin. They call them toothed whales. So this is extant. Extant means it's still around, still alive. It's a fancy sciencey word for not extinct. So it's not extinct, it's extant. Fancy. And here's a nice diagram of the whale evolution. Obviously people aren't in this. That's just there for size. So we see our Pachycetus, we see our Ambulocetus. Here's one I didn't show you, Myocetus. Here's Rhodocetus. Here's Durodon, we looked at that one. And what the heck is that? That is Basilosaurus. That is the creepiest whale I think you're ever gonna see. When they originally found that, they thought it was a sea serpent, but it is a descendant of the whales. It has like a lot of the others, it has a blowhole that is not above the eyes, but in every other way, other than in creepiness, you can tell that that is a whale. And then lastly, we have the orca, right? The giant dolphin, the killer whale. So here's our guy. Here's the one we've been talking about. We've been talking about this creature that was an ancestor of whales and hippos, right? And one group of these guys went one way and became hippos, and one group changed a different way, and over a long period of time turned into whales, right? So this is Anthracoteres at about 60 million years ago. So one group of Anthracoteres changed and evolved and eventually ended up making hippos. And one group changed and evolved through time, lots of extinctions, lots of changes, and eventually became the giant rulers of the sea, the giant ocean-going mammals, the largest animals that have ever lived, the whales. So hopefully you guys have enjoyed looking at some of these fossils, seeing some of the changes, and there's a lot more to come. There's still a lot more holes in the fossil record and a lot of specimens that we still have to find. It's really difficult, but slowly but surely, you know, we're piecing things together. This is what we do in biology. We keep working with the evidence we have, and we keep looking for more evidence. So, yeah.